Here's a big problem, which you are not going to like. When we standardize the inputs, we also standardize the dummies. This is bad practice because when we standardize, we lose the whole interpretability of a dummy. If we had left them as zeros and ones, we could have said, for a unit change, it is 7.2 times more likely that a person will be excessively absent. A unit change in the dummy variable universe means a change from disregarding this dummy to taking only this dummy into account. So, if the reason is reason 1, we would have said it is around 7.7 times more likely that a person will be absent compared to no reason given. However, we standardize the reasons, and now a unit change is completely uninterpretable. The predictive power of the model is still valid, and it is a good classifier, but we don't know how the different reasons compare. This is a problem, since those are the most important features. This brings us to a correction of our code. Good thing we had all those checkpoints. Maybe they'll help us do that effortlessly. I'll go back to the part where we standardize the data and put all the code in comments, since we won't be needing it. Now, I'll copy-paste some code that I've prepared prior to this lecture. The idea is that this is a custom scalar based on the standard scalar from sklearn. However, when we declare the scalar object, there's an extra argument, columns to scale. So, our custom scalar will not standardize all inputs, but only the ones we choose. In this way, we will be able to preserve the dummies untouched. In practice, we would avoid this step by standardizing prior to creating the dummies, but we didn't do it this time, so we can show you yet another nifty tool. So, let's see how this will work. First, we have the custom scalar class. It is no different than the standard scalar in the way it works. You don't necessarily need to understand the code. All you need to know is how to use it. Second, we must choose the columns to be scaled. To see what columns we've got, we must return to the last checkpoint before we standardized. This seems to be the unscaled inputs variable, so let's see what its column values are. Alright. Third, we will create a new variable called columns to scale that will contain the names of the features we'd like to scale. Therefore, we will omit the dummy variables from this list. Finally, we can declare the absenteeism scalar. It is equal to custom scalar of columns to scale. That's all. Nothing complicated. As before, we will write absenteeism scalar dot fit of unscaled inputs. Finally, we will create a variable called scaled inputs equal to the transformed unscaled inputs. I'll also display the result. As you can see, all our dummies have remained untouched. And that was the whole point. Since our code is very well organized and the data frame in this form is good to go, we can go ahead and execute the following cells until the end. On the way, I'd like to note that our model accuracy has fallen by a bit less than 1%. That's not unusual, as we basically changed 5 input features. We've lost a practically insignificant amount of accuracy, but I guarantee you, we've won interpretability. Now that we are all set, we can discuss the coefficients table once again. Thanks for watching.